So our next speaker for the day is going to be Wong from Viavi Solutions. His talk's going to be on moving beyond 5G technologies and trends, and a little bit about Dr. Wong. Dr. Ian Wong has been in the wireless field for over 20 years. He's presently the Director of RF and Wireless Architecture in the CTO office at Viavi Solutions, where he's leading RF and wireless technology strategy standards and architectures. Also the current co-chair of the Test and Integration Focus Group in the ORAN Alliance. From 2009 to August 2020, he was with National Instruments, where he was a section manager of wireless systems for the research and development, where he led development of many real-time end-to-end 5G wireless test and prototyping systems, and managed the company's 3GPP wireless standard and IP strategy. From 2007 to 2009, he was a system research and standards engineer with Freescale, and we are really happy to have him today. His current research interests include 5G wireless systems architecture, standards, and algorithms, with the particular focus on advanced physical layer technologies like millimeter wave and massive MIMO. Thank you, Dr. Wong, for joining us. The stage is yours.
Thank you, everybody. Thank you, Ashutosh, for inviting me here. I think it's been 7 years since we started the IEEE 5G Summits, and it's a pleasure for me to come back here after 7 years, and I'm still employed and still in the telecoms industry, so that's a good thing, right? I don't know if I started in 3G LTE days, and they call it LTE long-term employment, so it looks like it's holding up. It's not bad. Anyway, so I think, as with every generation, once people start deploying and they feel good about it, researchers need to think about what's next. And I think that's kind of what we will attempt to do here, as with a lot of the speakers before me. And just jumping right into it, and although I have kind of participated in a lot of IEEE activities, probably a lot of you folks are not familiar with Viavi, so I'll just spend a little bit of time talking about the company that I work for. So we are a test and measurement company, and we're basically the network test and measurement company. Everything related to the network we are working on, all the way from radio networks all the way to core. And we're a trusted partner for over 200 service providers around the world, the biggest service providers, the biggest network manufacturers, like we heard from Ericsson, Nokia, and others. Also hyperscale cloud providers and system integrators, and over 300 partners. We're a global company, over $1 billion, and then 3,600 plus employees, and I am but one of them. In terms of innovation, so we've been in the field for a long time. People don't know that our company is actually 90 years old. It's changed names a lot and had a lot of acquisitions along the way. But we're in 30 different market segments and data centers. And in fact, we have 1.6 million instruments deployed around the world. And if a cable guy came into your house to make some adjustments, or maybe the fiber guy, chances are they actually have a Viavi instrument in their case that you just didn't know about. And so that's kind of who we are. As far as like how we see things, and because we are involved in pretty much all of these networks, from radio to fiber to access, transport to data center, we feel that really working in these silos are really not enough. There's always these network silos, from the wireless guy to the IP networking to the transport guy. They kind of never talk to each other. Workflow silos, right? People who do R&D. Like, when was the last time an R&D person actually talked to somebody who was operating or actually troubleshooting a network? We feel that as we transition away really from these point networks, we heard a lot about 6G being this new disruptive way of doing things. We also feel that we have to move away from silos. We see it as we need to be able to look at any network, any workflow, any persona, any cloud, and for it to come together with full visibility. And that's really the only way we can manage the complexity of 5G and beyond 5G and 6G. Basically view your entire network end to end, Depending on your persona, you can see how you want to see your network. And finally, automation is key, right? And allowing to use a digital twin as a sandbox to truly experiment with things. And that's how we see the world. So moving on to specifically about 5G, Viavi, we're kind of, some of measurement first. So we're known as the emulator company or UE emulator company. Basically, our UE emulation capabilities are used by virtually all base station manufacturers in the world. We're the first to come up with core emulation, complete suite of O-RAN specifications for testing, and also 5G and aviation kind of testing is something that we first came out with as well. We're engaged with various aspects of the industry. We have deep experience, and again, any cloud, we're running on it. But enough about Viavi and 5G. Let's talk about where 5G is, and I think we've heard a bit about this, and I would, there's always something about the data, and maybe some of you may disagree with this, but at the end of the day, 5G is here now. It's really deployed, and the way this is data from Viavi, and we count it in terms of how many cities have actually deployed 5G, and it's close to 2,000 cities around the world. And again, like how you slice the data is how sometimes you think of things, and I'll ask the audience here, maybe I don't know online, but there's Americas, there's the EMEA, and there's APAC. Like which region do you think has the most cities deployed 5G? Who says Asia? Who says EMEA? Who says Americas? Some APAC, some Americas. All of you are wrong. It's actually the most cities with networks, 5G network deployed is actually in EMEA. Again, a city in EMEA is probably a few 100,000 people, but a city in China is maybe 12 million. So, I mean, from a city standpoint, in fact, it's actually EMEA that has a lot more deployed, and close to half, and 689 APAC, and America's 419. How about countries, right? Now, who do you think are the top 3 countries? Who says number 1 is China? There's one. Who says number 2 is America? Nobody. Who says number 3 is the Philippines? Hey, we've got somebody who actually said, and in fact, that's exactly the top 3, and which also surprised me a lot. And I kind of like this data because I actually am born and I grew up in the Philippines. I live in America now, and that's where I work, and I'm natively Chinese. So there you go. That's the reason I like this data. But anyway, from a 5G standpoint, bottom line is it's deployed around the world. It's active right now. There's still a lot of kinks to work out, but then, why are we talking about beyond 5G now? Come on. There's still a lot. I mean, it doesn't mean that we're done, right? There's a lot of problems to solve, but we kind of have to think about what's coming next. And usually it starts with 3GPP. We heard a little bit about 3GPP. And from a timeline standpoint, 3GPP has these concept of releases. A release is about 1.5 to 2 years. And you can think of 5G as basically the past 3 releases, right? They started with release 15 sometime in 2018, basically foundational EMBB technologies. Release 16 saw the initial use case expansion, right? The triangle that people saw. Really, release 15 only focused on the EMBB triangle. Release 16 started to expand beyond that. And release 17 is the further expansion where we added non-terrestrial networks and started talking about and focusing on IoT. We are now in mid-2022. The 3GPP plenary was actually just last week, and one of my colleagues were there. I was supposed to be there. I missed that flight. But basically, the next 3 releases is what we're calling 5G Advanced. Where I would say this as, just like LTE Advanced, right, in the 4G era, 5G Advanced here is you're now evolving 5G, not revolutionizing, evolving, by, from your learnings from the previous deployment, right? We're still deploying it right now. As we heard today, millimeter wave was this big hype going into 5G, and it's still, the ROI is just not there yet. And I think we're learning on those deployments. We're leaning towards now more advanced use case, right? We hear a lot of AR, VR, XR, this metaverse. And again, using the latest technology developments. And so far, if you can pick one technology that is really transforming everything today is AI and ML. And during the initial days of 5G, it was kind of just scratching the surface. So we're now trying to really exploit that for 5G advanced. And just like the previous generation, we only figure it out actually in the next generation, right? And 6G is really the next big leap. And we see that kind of happening, and we saw some of the timelines from Misha's slides, like sometime in 2025, there will be a workshop in 3GPP that says, why don't we start thinking about what 6G needs to look like? And that's kind of how we also expect it. And in terms of release 18, right, start from where you are. We're actually in the release 18 cycle. And, you know, in the SA or system aspects, you know, you can see that, you know, I picked out some of the highlights of the work items in release 18 today. There's XR. You see AI/ML for the system side, intelligence and automation, 5G system with satellite backhaul, non-terrestrial networks, and vehicle-mounted relays. You see that as really a response to how do we really improve on millimeter wave coverage, which is the biggest issue. And same on the radio access network side. Expanded, you know, improved NR positioning, right? Like understanding how to use wireless to really do better localization. AI/ML for both the air interface, which is initialized, you know, basic initial study on that in release 18. And also AI/ML for the RAN, this time, you know, true work item phase, right? Like how do we really leverage all this data that the radio access network gets to improve the performance and automation and optimization. Evolving the air interface is still happening, you know, duplexing, you know, full duplex, you know, running into 5G, there was also a lot of hype there. They're now trying to figure out what types of duplexing really make sense, you know, moving forward. And again, trying to solve the millimeter wave problem with mobile IAB, or integrated access and backhaul. So these are the things that are in release 18 that, and usually how you see it evolving is like, you know, the LTE Advanced was kind of almost like a premonition for 5G. I would see, you know, 5G Advanced as a premonition for 6G, because that's kind of the things wherein I wish we were able to do this, and as we're starting to try it out, it's now breaking apart, and so we need a new generation. So that's at least how I see as you know, these are kind of the, you know, if you look at a crystal ball, these are the areas that 6G will likely look into. And this is how also Viavi views the world. And again, like Misha's slides, you know, as a wireless guy, I like hexagons, right? It's 6 sides, it's 6G, and it makes a lot of sense to actually think about 6 key vectors of research, at least from a Viavi standpoint. So first of all, you got to start with new spectrum. As with any new generation, there's always new spectrum, and that's kind of impetus to go to ITU and WRC and try to get more harmonized, global harmonized spectrum. So we heard a lot about upper mid-band. I would say I agree with Misha that really the sweet spot is mid-band, and going between 7 and 24 gigahertz, I think, is the new sweet spot wherein you can do truly massive MIMO, best coverage versus capacity trade-off. We really need to figure that out. Sub-terahertz, I would say, is interesting for RF people because they really need to kind of keep on pushing the boundaries. But, you know, let's figure out millimeter wave, really, in 5G Advanced, and hopefully we design it right from the get-go in 6G. Intelligent spectrum sharing, that's extremely important. I mean, spectrum is one of the most scarce and important assets. How do we intelligently use it? How do you use AI and ML, right? Machine intelligence to actually help us manage spectrum better. New topologies, right? NTN is something that was also added in 5G. We're now trying to learn more about it. What if we're able to design from the ground up, you know, the interworking of satellite and drones and HAPS and terrestrial networks, right? The concepts of cell-free massive MIMO, distributed massive MIMO, and full duplex and mobile mesh networks, and mobile IAB. We're starting to see some of that in 5G Advanced. We see that as coming to full fruition in 6G. Again, AI/ML. You know, you see it everywhere now. It's transformed how we think of things. For a signal processing guy, it's just really nonlinear signal processing with a much more data for training. But now you can use that across the entire network, all the way from the PHY, designing the PHY, potentially even implementing the PHY with AI/ML. That's what the study in Release 18 is about, to the MAC, to the network side. But then all the way up to managing and optimizing the network, which already is happening today, right? For example, with the RIC in Open RAN. The third aspect that we see is, of course, expanded verticals, right? If you look at kind of the business model for carriers, 5G was supposed to be where we expand beyond business to consumer, right? It's beyond the smartphone. But hey, guess what? That's still the majority. That's still where everything is happening, right? So we really need to figure out how to expand into these new verticals, make them really successful. So there's really any chance of expanding this macro network capacity into the verticals that need it. AR, VR, metaverse, expanding to precision sensing and localization for automotive and IIoT applications. That's kind of a few areas that we see are most promising. And one thing I haven't heard too much about yet today, and not just because Viavi is a fiber and optic company, but this optical wireless coalescence, right? I chose the term coalescence instead of just convergence, because convergence is when two things just come together and happen to be there at the same time. Coalescence is truly merging the capabilities of optical and wireless, right? In chemistry, coalescence is when two things come together and truly become one. And we see this as really the impetus in 6G is how do we truly harness, as you move into upper terahertz, it's getting even closer to optical frequencies, like, free space optics, especially between satellites. Satellite to satellite is definitely, for a prime area for free space optical communications. And radio over fiber was talked about. And I think these are the areas that we see wherein there's a lot of thinking that needs to happen where both optical and wireless people, again, breaking down silos to work together to think about how best to use these technologies. Because, we think of IAB as a way to reduce costs of fiber, but then, we also heard that fiber is probably one of the more cost-effective ways of getting internet into homes today. And so, but, wireless may be changing that. Instead of that being competing with each other, how do we really leverage these two technologies together? Security and resilience, obviously, right? As we become more intelligent, as we become more data-centric, it becomes more critical, right? We heard about zero trust principles today, post-quantum security, and having really resilient infrastructure, because again, we're trusting the networks more and more as we speak, and we kind of need to. And finally, end-to-end cloud native. Again, this is not new, but we're talking about truly end-to-end cloud, right? Distributed cloud platform all the way down to potentially even your device. Like we heard about networks flattening. We heard about the cloud being one hop away. How about the cloud actually on your device, right? Maybe that's no longer called the cloud, but then you're truly potentially even 0 hops away from where you want to communicate. And that's how we see it. We see the same way in test and measurement, right? Wherein if everything is cloud-based, all the way to the edge, all the way potentially to the device, it allows us full visibility, allows us full optimization. Again, like going back to the principles of network disaggregation, allowing us to truly embrace that cloud principle. And with that, I will actually conclude earlier so that you can catch up with time, these are just a sampling of where Viavi is looking at today. So we're a full member of NextG Alliance. We contributed to several of the white papers that have been published. As I mentioned, as was introduced, I'm a co-chair of the O-RAN Alliance. It's something that is near and dear to my heart. This is how I believe future networks should be built from the ground up. It's truly disaggregated and truly open. 1.6G is an effort in Europe. Beyond 5G promotion is in Japan. So all over the world, we're also beginning to fund research institutes here in the U.S. And of course in Europe, the Locus project and the 6G Brains project in 5GPP. So bottom line is, we're looking for partners. We want to collaborate with the industry. I think we have a unique position in the ecosystem that we're the emulation company. Anything you want to do, we can emulate. Anything you want to do, both optical and wireless, we can test. So we want to collaborate with you guys, both academia and industry, to make 6G happen. All right. Thank you. That's it.
Thank you, Dr. Wong. We actually have a few questions, probably both from the room and online. Actually, the first one, if you could go back to slide number 9, there was a question to have you elaborate on slide number 9, specifically AI, ML versus signal processing, and just offer a few more thoughts on that concept related to slide 9.
Sure, yeah. I mean, I'm partly joking, but really not. I mean, if you look at AI, I mean, AI, at least the fundamental aspects of convolutional neural networks, right? I mean, I don't know if you remember linear systems and signals. We talked a lot about convolution. But a lot of our theories, we like them neat in signal processing, and we like the linear model. And if it's nonlinear, maybe second, third order, and we're happy with that because we can do some proofs and we can make it converge and we can simulate them easily. I mean, the truth is, AI is an extension of that. I mean, just look at ICASP. ICASP is a premier conference signal processing. Like 10 years ago, it's really all linear, and then a few years after that, it's now all about convolutional neural networks and AI and ML, and that's kind of, and I see those two, fundamentally, their mathematical principles are very similar, and I would say, a lot of the researchers, I'm sure, agree with me, because look at their proposals today, they're all about AI, ML, and they're signal processing people, so.
Awesome. Any questions from the room before I go back to the chat? Do we have one? Oh.
Well, I very much agree with your intent cloud native, but instead of diving into that, I want to go back to your comments in millimeter wave. So I feel like I've sat through a lot of presentations over the past year and came away with the conclusion that even though this is being deployed, it's nowhere near fully baked. In fact, it's a couple of new research insights short of being commercially viable. So you suggested that it might be ready for advanced, but do you really think it's ready for these next couple of releases and it's going to suddenly become commercially viable, or are we short a couple of new research insights?
That's a great question. As with any technology, there's always a technology question, or maybe fundamental science research question, and also a business question, right? I think millimeter wave right now is really more of a business question. From a technology standpoint, we've matured quite a bit from where we started. We know how to build the chips. We know how to make them low power. There's some issues with coverage, and that's why mobile IAB, right, integrated access and backhaul is a key thing. Smart repeaters is a key thing. Again, it's really about making it viable for operators to actually deploy this in a larger scale, is I think the challenge for 5G Advanced. I see that going to be being solved in the next 3 or 4 or 5 years as we progress in 5G Advanced and we figure that out. And I'm also kind of more of the pragmatic camp, wherein one thing we try in one generation, we finally figure out in the next generation. So I see 6G as saying, hey, you know what? We know how to do millimeter wave from the get-go.
Okay, we have time for one more question. You know what? I'll take the last one that popped in here. Are edge/terminal networks, LANs, for example, prepared to deal with performance of 6G, specifically low latency, high rates? Will smartphones be faster than humans? Question mark.
Will smartphones be faster than humans?
Maybe in thought, maybe in processing and thought.
Not like when I throw it out, if a human can actually catch the smartphone. No, I think, yeah, in terms of maybe the processing power and all that. I mean, it's, yeah, like if my, let's think about it. Again, like I always like to think about what is the true value of something, versus another, right? Like some people might say, oh, you know what? Like AI will replace the, maybe the standards engineer, right? Like people who go to standards say, hey, why do we need, 500 people coming together to form standards? Maybe you can just deploy robots and use AI. So I would say, the human capacity for innovation and creativity will always be needed. But there are some things that, just like, computers have taken over manual calculation and slide rules and all that. I mean, there's going to be, I would say, humans will always have the upper hand until Terminator comes, and then we're all dead. But anyway, yeah, that's kind of my thought. Yeah.